All right, this is our senior design project. It's called Innovative Compressor and Mud Pump Design. I'm Willard Hatcher, and as stated above, the background of our project proposal will be revolving around the usefulness and applications of mud pumps in the oil industry and our proposed idea of a more efficient and effective mud pump. Mud pumps are a very essential part of the operation in the oil field, as it is used to circulate the drilling fluid into and out of the well, as well as carry rock cuttings back to the surface. Without them, it would be impossible to have a successful and lucrative operation. Therefore, because of their importance, we thought it would be a good idea to try and come up with something that could possibly enhance their effectiveness. More background about the applications of today's mud pumps is that they pump drilling fluid down into the well through the drill pipes and releases them through the drill bit at the bottom of the hole, then flow back up to the surface with valuable ingredients such as rock cuttings, which are able to give the petroleum engineers knowledge and information about the formation in which they are drilling. They are also able to control the rate at which drilling fluids are circulated down the drill pipes, and for instance, at times such as kicks, it's very important to regulate the rate of circulation to avoid undesired consequences. Furthermore, the proposed idea my group has is to implement a 4-piston ram mud pump engine. With such an apparatus, it might be possible to circulate the drilling fluid with more speed, effectiveness, and efficiency. The pistons would be on opposite sides of each other, working simultaneously to lubricate the drill bit, maintain a more controlled hydrostatic pressure, and circulate rock cuttings back to the surface. It's a complex idea, but if it was able to be pulled off, it could potentially recreate the future of how mud pumps are created and operated.
Hey guys, I'm Pat Kelly. Our executive summary for our project is what we plan on completing and submitting our final proposal and presentation. We plan to identify or individually gather research in our spare time over the break to help keep the topic fresh in our minds. We need to communicate with our sponsor company, Ariel Corporation. Data will be requested from them and several other mud pumps and engineering companies to compare and contrast different designs and tasks. We will use a collaborative approach to form a prototype of our own design to be tested further for feasibility. Short testing trials and continued research will aid in the design refinement process as we hopefully reach a more efficient design with an economically producible cost to manufacture. So this is a conventional mud pump design. As you can see, it's actually only got one acting piston. Typically they come in a triplex pump, which would be 3 of these in a row. You have your flow line, and because it's a single acting piston, you actually have a lull in the flow. Our design is geared around combating this, as you can see in the next slide. So we have 2 pressurizing chambers with 4 pistons to give a constant flow process across. You can actually run 2 separate flow lines or have them converge into one larger flow line, and it's all driven by one singular camshaft for an easier input energy and a significantly reduced vibration. Go ahead. This is an example of our pumps stacked sequentially. This can be done to save platform space if you're on an offshore operation, or just if space is tight on whatever platform you're working with. It can also be set in opposing times so that the balance of them is perfect.
I'm Andrew Kilgore. I'm going to be talking about the advantages of this configuration. Our configuration requires less input energy for the equivalent output of conventional pumps. It offers the option of 2 separate injection lines or a single line with larger displacement. It can be stacked sequentially, aiding the drill ship / platform space utilization. Indicates adverse vibration distortion from pumps and measurement while drilling operation. It also produces 50 to 80% more power output per unit piston displacement. Actually, based off a test run by SPE International versus the opposed piston motor and the triplex motor, which is commonly used as a pump today in most oil industries, they compared the 2 motors, and based off the results, the opposed piston engine proved to have a much better thermal efficiency based on 3 major aspects: reduced heat transfer, increased ratio of specific heats, and decreased combustion duration. It also has significantly low fuel consumption requirements. In fact, it has been shown to have a 10.2 to 0.3 lower fuel consumption than most triplex motors. It also provides a much more simple design and reduction of parts, which requires it to have less space utilization.
This is our Gantt chart for scheduling how we will divvy up the workload from now until April. At first, we started with finishing our final proposal on the 21st of November. It took us 11 days and we all worked on it evenly. And then the next step was the 1st of December to finish our presentation, which we are presenting right now. It took about 8 days, and that was all of us working on it at the same time. And from the 12th of December till about the 8th of January, we're going to take a break and think and sit on what we've researched all semester. And we'll start again on the 8th of January to begin a second research phase. And then immediately after, during that, on the 8th of January, we're taking about 7 days, and all of us are going to start researching into specific engine types for mud pumps and compressors. And on the 15th of January, John and Andrew will work for 7 days on researching into current mud pumps. And then at the same time, Patrick and Trey will be researching into newer mud pumps. And right after that 7-day period, we'll be looking into the application of new engines. And who will be working on that is John and Trey. And then a week after that, Patrick and Andrew will be we're asking people in the industry for input onto our senior design project. Moving on to the 5th of February, John and Patrick will be researching into current compressors that are being used today. And then at the same time period, Andrew and Trey will be researching into newer compressors. And then moving on to the 12th of February, we plan to have John and Andrew research the pros and cons of implementing new equipment on rigs. And then a week after that, Patrick and Trey on the 19th of February will research if onshore or land rigs apply better to our idea. Moving on to the 26th of February, nearing the end of the semester, all 7 of us will research the cost analysis of pumps and compressors to see which ones work better, which ones aren't as cost effective. And then finishing it up with the 5th of March, ideally, all 7 of us will join all of our findings through the entire past 2 semesters of research into one single document. And that will leave a whole month before April to condense our findings and formulate it better and make it to more apply better to our final presentation. And to close it all off with our budget is simple as it consists of paying just for the access to scholarly articles. And each article costs around $5 to $10 each to access. We plan to need around 18 articles throughout the entire semester for all of our research and findings. And our total budget comes around $140 plus or minus $10, $15 to account for more articles or less articles that we need to formulate our whole research.